All right, so I think we'll get started. It's about 22, so thank you for coming here, spending your last session of the day with me. I appreciate that. So my name is Jakob Ehn, and this is going to be a lap around Azure Devops. So the title implies that this will be kind of a wide session. I won't go deep into the details, so I'm going to try to cover as many of the parts as possible, and it's mostly going to be a long demo. So I'm going to do some slides in the beginning first. So, as I said, my name is Jakob Ehn. I work back in Stockholm, Sweden for a company called Active Solution, where we're building cloud-based solutions on Azure, and of course we're using Azure Devops to do it, to ship it. I'm an Azure MVP. I blog a bit, and you can follow me on Twitter on this address over here. So, I just want to start with saying that naming is hard. We know that in this business. How many here have been using Azure DevOps or any of the previous versions? So a few of you, yeah. So has anyone used what was originally called Visual Studio Team System 2005? Great. I was back there. It was a rough time. So this was the first version of what we now know as Azure DevOps. The next major version was 2008. And 2010, Microsoft rebranded it into Team Foundation Server. They dropped the team system and called it Team Foundation Server. And this was a major release. A lot of companies started using TFS in this version, and a lot of very nice improvements in this version here. In 2012, Microsoft did a kind of an internship project actually over the summer to see what would it take to take TFS, this on-premise product, and run it in the cloud. To run it in Azure, on Azure SQL. And it turned out it wasn't that much of a job originally, and they actually launched this later that fall as a preview. And they call it Team Foundation Service, which kind of makes sense. You have Team Foundation Server on-premise, and now you have the service. And so adoption grew pretty fast. I liked it, so I actually spent a lot of time with some friends and published a book called Pro Team Foundation Service. It's great. And I think it was 2 or 3 weeks after this book was published, Microsoft decided to rename it again to Visual Studio Online. And that didn't help the sales of this book, I can tell you. It dropped dead completely. So away it went. So, but the thing was, Microsoft started adding more services around this, like application insights, load testing. So they wanted to kind of broaden it. It's not just Team Foundation Server, it's something more. The big problem with this name was that everywhere Microsoft went on conferences and so on, people thought that, okay, Visual Studio Online, that's Visual Studio on the web, right? It's like a web editor. Everybody thought this, not everybody, but a lot of people did. So they kept fighting with this branding issue. So once again, in 2016, they renamed it again to Visual Studio Team Services, pretty close to the original one. So for us hardcore fans, we still had like this VSTS acronyms. We had some T-shirts that we could pull out and reuse again. So we were kind of happy. And this name stuck for a while. But again, Visual Studio also is kind of a problematic branding name for Microsoft, because they want to reach outside the traditional Microsoft sphere. They want to target developers that maybe are not on the Microsoft platform, because you can really use any language or any platform when you're using VSTS. So at the end of the day, they wanted to drop the Visual Studio name, and they looked at branding, and Azure is a really strong brand nowadays, not just with Microsoft developers, but also all developers all over the world. So last fall, they renamed it once again, hopefully the last time, but who knows, into Azure Devops, which caused a lot of jokes, because Microsoft and a lot of other companies say you can't buy DevOps. It's a cultural thing and so on, but here they go trying to sell it as Azure Devops. But this is a set of services now, the Azure Devops services. So it's the same tool as VSTS, but it's more branded, and the idea is that you can pick and choose from these services. So I'm going to quickly just walk you through these different services, and then I'm going to start on a demo to show you how this stuff works. So first up is the Azure Boards. So this is where you plan and track your work. So if you're doing a Scrum, if you're doing Kanban, you can use your process and track your work here. all the way from the idea all the way to the release of your software, and you get traceability all the way. Azure Repos, that's for hosting your source control. Now, the original source control system is nowadays called Team Foundation Version Control, and that's still there. It's a centralized source control system. But everybody is kind of jumping on the Git bandwagon the last couple of years. So you can pick and choose here. You can use actually both of these source control systems if you want to. And this is standard Git. You can use any Git client out there. It will work just fine against Azure Repos. Azure Pipelines. This is for shipping your product, for building it, run tests on it, and deploy it. As I mentioned before, this is for any language, any platform. Doesn't really matter what kind of language you're using, what kind of platform you're running it on. Microsoft supports cloud-based agents for Windows, Linux, and Mac, so that you can just start using, or you can set up your own build service if you want to. It's very extensible, lots of built-in tasks, and you can fetch more from the marketplace. And it's a really good offering for open source projects. So if you are using open source, Microsoft provides unlimited build minutes using Azure Pipelines, and you get up to 10 concurrent build jobs. So that's a really nice offering from Microsoft. So if you're developing a source in the open, you really should check this out for building and shipping your applications. Azure Test Plans. This is for doing acceptance kind of testing, manual testing, exploratory testing. And I mean, still a lot of companies still are using Word or Excel to have their test cases, and they run through a set of regression tests. Here you can define those test plans, your test cases in Azure Test Plans, and you get assistance when you run the tests. So the testers can now easily run through the tests, capture screen information, where user clicks and so on, and if they find a bug, you can capture that information and send it right back to Azure Boards. So you get a bug with actionable insights into it, which is really nice. And also you get this end-to-end traceability all the way back to the original commit. The bugs will be linked to the requirements that you're testing and so on. And the last service is called Azure Artifacts. So this is for storing any packages that you might build as part of your product. So it could be a NuGet package, NPM, Maven, and so on. And you can also use it as an upstream feed, which means that you can kind of use it as a proxy. So maybe you don't want everybody to just download anything from this available package repositories. So you can kind of add some governance into it by using this stuff. But the idea is that you don't have to use all these services if you don't want to. You can pick and choose. If you're already using Jira for work item tracking, or if you're using GitHub for source control, that's just fine. You can keep on using it and just use these services that you want to. And eventually you will be able to buy these services that I just talked about individually. At the moment you can buy Azure Pipelines individually. The rest of the stuff kind of comes along. But at the end of the day you will be able to buy this as individual services, which will be very nice. So the demo they're going to show you, I'm going to use a fictitious company called QuizBox. They are building a quiz application. So it's a very simple web app with a web API and a SQL Server in the backend and some admin tools. And to kind of show you different scenarios here, I have two teams in this company. So I have the game team. They're building the web game. So they're using Azure Boards. They are doing Scrum. So they have the backlog and they do sprint planning using Azure Boards. They have all the code tucked into Azure Repos. So they have multiple Git repos for their source code. They're also actually publishing some common code into a NuGet package using Azure Artifacts. They're using Azure Pipelines to build the application. So this is a containerized application. So they're building Docker images and pushing it to a Docker registry. And then eventually they're going to deploy it into an Azure App Service using these containers. They're using test plans to run manual acceptance tests. And they're using App Insights for monitoring the application in production and make sure that it's healthy. On the other hand, the admin team, they're also using Azure Boards, but they don't do Scrum. they work more on a kind of a maintenance process, so kind of following a Kanban process where they just keep adding new PBIs and trying to work on what's most important at the moment and ship that into production. So different way of working, but using the same tools. They have all the source code over at GitHub, so they're not using Azure Repos. They also use Azure pipelines to build that code, and they're using YAML builds, which I'm going to show you in a bit, which is a different way of defining these build definitions. They're not deploying this stuff. This is application admin tools that are running on premises. So they're using deployment groups, which is a way to deploy applications onto multiple servers, running in the backend somewhere. And they're using the test tools, there's test plans, but they're not doing like formalized test plans. They do exploratory testing, where the tester can just browse around and see if everything looks good. But they get this tooling that helps them to actually get meaningful data out of this test run. So I'm just going to walk you through 2 scenarios, and hopefully I'll have the time to finish it all. So we're going to go all the way from looking at the PBI, creating a pull request, kicking off a build, running some acceptance tests, and look at how can you monitor this stuff before it goes into production for the game team. So roughly the same thing for the admin, but here we're using using GitHub instead. And we're going to see how can we deploy this stuff to on-premise service instead of Azure. So let's jump into the demos. So first of all, just to very quickly show you this fantastic demo application. This is the Quizbox app. So I can start a new quiz here. And you can select the category, and you get a set of questions, and you select the correct answer or the incorrect answer, and you type your name and post a score. So very simple application. Of course, that's not the point of this session. So let's head over to the Quizbox product site at Azure Devops. So over to the left, you can see these services that I talked about. We have the boards, repos, pipelines, test plan, artifacts. So I've enabled all services on this project because I'm using all services. Now what I can do is that I mentioned before, I don't have to use all these services if I don't want to. I can actually go into settings and say that I'm actually not using artifacts, for example. So I can just remove it, which means that it won't be visible anywhere in this project. And it kind of makes sense, because this is a big tool suite, and it's always been a bit of a problem that people get kind of lost because there's so much in here. So if you're not using some of these services, you can just remove them and they won't be visible. So if I refresh now, the artifacts hub will go away, and any menus or anything will be disappeared. And another thing to note here, I'm going to re-enable this one because I'm probably going to use it, is also that we have this visibility thing here, which are currently set to public. And so Azure DevOps now supports complete anonymous access. So this is if you're doing kind of an open source project on Azure DevOps, you can mark your project as public, meaning that anyone can actually access this one. So you guys can actually access this project with a read-only access, because I marked it as public. And since it's public, I also get this offering from Microsoft that let me use Azure pipelines for free with unlimited build minutes. So that's pretty nice. So back to the overview. As you can see, you get kind of a start page here. I've added a simple wiki, and I get some project statistics to the right here. The main thing when you want to visualize information is that you're going to use dashboards, which let you visualize information from all these different services. And these dashboards are tied to the different teams. So it's a bit slow now, but up here you can see that each team will have a set of dashboards. So the admin team has one dashboard, the game team has 3 different dashboards. And it makes it really easy for you to to fetch information from, about source code commits, about test results, about finished builds, all this information, and visualize it on dashboards. And they are really easy to create and modify. You can just add a lot of widgets that come by default, and you can install additional ones from the marketplace that is available. So let's head over to the game team. So they're using a Scrum process, as I mentioned before. That means that they have a prioritized backlog here with the PBIs and the bugs. And what they do, they have a sprint plan. You can see it to the right. We're currently in sprint 3. And I also have defined sprint 4 and sprint 5. So we're kind of halfway into this project. And if I go to the sprints, we dive right into the current sprint to see what it looks like. So this will show you now the task board that you will typically use maybe during a daily stand-up. So you see each PBI to the left here. So that's the requirement that you're currently implementing. And each PBI has a set of tasks where you can easily, for example, update remaining work. You can reassign it to different people. And you get a sprint burn down, all this stuff that you kind of expect from Scrum tooling. So when you do a daily stand-up, you can, for example, say group this information by people, and you can just take turn and say, did I miss it? Yeah. So you have your team, and you just walk through and say, okay, Jakob, what's up? What are you doing? Okay, these are my tasks, and then you go to the next person, and you just update information on the current status. So, I'm going to start by making a change here. If you look in the current sprint 3, I have a PBI called select random category. So the idea is that when I start here, I want to be able to have Quizbox automatically select a category for me randomly. So this PBI is, I already created it. It's over here. It's on the top. So it makes sense that I actually work with it now. So open it up. You can see the information that I added for this PBI. So we have the description for the PBI. We have some acceptance criteria once it's loaded. So now I'm using the default Scrum template, and everything here is customizable. If you want to add more fields, you can do that. If you want to change the layout, you can do that. You can create customized, it's called process templates here. If you want to add more stuff or maybe remove information that's not relevant to you, you can do that. And so I prepared this change already. So let's head over to Visual Studio that this team is using. So I already have these changes running here. And so I compiled it and I run it locally. So this is now, I'm going to just show you the local instance now with the change. So when I run Quizbox locally now, I should be able to see a new option on this screen, which is a little dice. So if I select the dice, it will select a random category for me. Okay. So let's push this up to Azure Repos. And it's going to type a comment. Implemented random category. So typically what I want to do, I want to associate this change to get this traceability that I talked about. I want to link this commit now to the work item that I'm currently working on. And by just using the pound sign, it will automatically search. I can now search for work items directly inside Visual Studio, which is really nice. So I can easily find my PBI here and push it. So this traceability is really important. I mean, right now I know that this is what I'm working on. 3 or 4 months from now, I'll probably forget why was this change made. I write a comment about the change, but that doesn't really explain why did you do that change. And that's really the reason for the PBI or the bug that I'm working on. So it's really nice to get this information. And this information will also flow along all the way into the builds and the releases. So when we deploy this, we can see that these are the PBIs or the bugs that are going into production. So, and of course we get pretty good integration here. So when I publish this branch, Visual Studio says, hey, maybe we want to do a pull request. But I also want to show you what this looks like if we go back to Azure Devops and I jump into the Azure Repos here. So let's go into the branches page here. I'm going to go to the pull request. So a pull request is a preferred way in Git or like a GitHub or Azure Devops to bring changes into, for example, the master branch. So that allows you to do things like code reviews and enable some policies to make sure that the quality going into the master branch is as good as possible. So currently I don't have a pull request, but it suggests that maybe you want to create one because you just published a new branch. So I'm going to create a pull request. And it's going to look at those changes that I made. And I'm going to get the default title. It picks this from the commits that I made. It already linked this pull request to the PBI based on that commit that I already did before. So the only thing I need to do now is to add the reviewers here. And normally I would select a team here and say that one or two or number of people in this team need to approve these changes. In this case, I'm going to select myself, which is not a good practice, but it's easier when I make the demo. And at the bottom, I can see that these are the changes that are going into this pull request. So I'm going to create it. And now, the people that are assigned as code reviewers, they will get a mail notification and say, hey, you got a pull request. Can you take a look at it? So what they will see is this pull request. Is it downloading? Yeah. So the purpose of a pull request is to do a code review, to have a discussion around the code, and you can comment back and forth, and I can keep adding changes to this pull request. So I can add comments to these changes as a reviewer. So I can add 2 individual lines or comment on files and say, this looks a bit strange, type some comment and save it. And so the initial developer will get also a notification about this, and you can go in and have a discussion around this code. And so it's a bit slow now, unfortunately. I'm kind of waiting to see some policies here, but I can't see it yet. Okay, so the idea is now that I have I made these changes. I can now do a code review, so that means I can now approve it. It looks good. And what also happens, I can't see it right now, is that it should also kick off a build to verify this pull request. To show you what this looks like when you configure it, so the idea is that you want to make sure that this branch is protected as much as possible when you go into the master branch. So these are the branches currently. You have the master branch, and then you have the random category that I just created. And the master branch now has some policies which I enabled that should be validated before anything can go into this master branch. And for some reason it's a bit slow now. So, oh, actually I didn't. So that kind of explains why the build didn't kick off. Okay, so that was my bad. So what you can do here, I can say that, okay, I want to make sure that I have a minimal number of reviewers, maybe 1, 2, or 3 reviewers. I want to make sure that every change going in here has a linked work item, as I showed you before. And I can also enable the build policy. So when I do this, when I do a pull request, it will actually kick off a build to actually verify this pull request. And if that build doesn't succeed, either if it doesn't compile or the test doesn't run, I won't be able to merge this change into master. So it's a really good safety net. Unfortunately, I forgot to... I've been changing this back and forth during the day, so unfortunately I left it in this incorrect state before the session. So what would have happened really when I did the pull request is that it should, kick off a build, which wasn't done now. But anyway, let's go back to the pull request and complete it. Come on. So we just have to kind of trust that these policies were actually evaluated and everything looks fine. So I'm going to go ahead and approve it. Which takes some time. So it looks good. So I'm going to do approve here. And so typically you would have maybe several people doing approve here. And when everybody has clicked approve, they can now complete this pull request. So when a pull request is completed, that means that the changes will now be merged into master. The source branch in this case will be deleted because we don't need it anymore. And we have a few more options here. So I'm just going to go ahead and... okay, so maybe I shouldn't have enabled this pull request. I actually, by accident, said that we have to have 2 reviewers, which is kind of problematic right now, since I'm only 1 people here. So sorry about that. So let's just change this policy. Isn't it always like this? It's blazing fast all day, and when you have the session, it's really slow. Well, what are you going to do? So let's change this one to 1. And go back to the pull request. Okay, let's try to complete it again. Come on. Let's do complete. Oh, okay, so all right, now we actually get to see this, what it's doing. So as you can see now actually I did enable these policies, which means that it's I can see them up here now. I can zoom in a bit so you can see what's actually going on here. So now these are the policies that I showed you before. So 1 reviewer approved, that's good. We have work items linked, that's good. But now this build is running to validate this pull request. So I can't actually merge it now before it's running. So while that is running, let's take a look at that build. So let's jump into the pipelines section of Azure DevOps. So now we're in the build and release part of this. So in this case, I have a few build definition here for the web app, for the API, and so on. And to the right, I can see the history of these builds. And you can see now that this top one is actually running right now. So that's running from the PR. And if we open it up, we should be able to see some live logs coming from the build agent. It's actually pretty fast, so it's already done. So this is the log output from the build. And if you want to troubleshoot the build, you can go into any of these steps and check out the logs for troubleshooting. So this is exactly the same thing that you would see if you run this, when you're building this locally. So and this information is streamed live if you're looking at the live build. So change to the summary. We get kind of a summary information here. So from the bottom to the top, I can see, it's kind of hard for you to see maybe, but you have the linked work items down here, the associated changes. These are the commits going into this build. I get some overview information about the build and the tests. So in this case, I'm running some unit tests. It's a whopping 6 unit tests. So, but at least I have 100% of them was actually correct. And at the top here, you can also see the build artifacts. So this is the output of the build. Now in this case, I'm building Docker images and I'm pushing them to a Docker registry. But in addition, I'm using some artifacts here, which is test assemblies and test configuration files, because I want to run integration tests later on. So I need to push them to the build, so I can use them later on in the pipeline. So let's get these changes now into master, because now the build is complete, which means that all my policies is now complete. And I can finally get my changes into master. So all policies should be green now. So let's do a complete. All right, so it's completing the merge request and saying that the changes is now merged into master. And going back to the build again now should show me that, again, that will now kick off a new build, but this time it's going to do it from the master branch, because I have CI enabled here. So you can see that if you have very good eyes, you can see that now it's building from the master branch. Before it was building from this pull request branch. But it's the same build running now. So let's take a look at what this build definition looks like while it's running. So let's hit edit on it. So build definition is really just a set of tasks that are executed in order. And you have two ways of creating build definitions. So I'm going to show you here the first one, which is now called like you're using a visual designer for adding tasks. So first up, you can select where should I get the sources from. So you have many options here. Now I'm using Azure Repos, but I could use GitHub or Subversion or Bitbucket, or a lot of different options here. And so down here I have the tasks. So in this case, the build starts off by versioning my assemblies, building and running some unit tests. I'm using some Docker tasks for building Docker images, and then I'm publishing back test results and these artifacts that I mentioned before. These are all out-of-the-box tasks. So if I want to add another task, I can just hit add here and search. So let's say I want to maybe add some other Docker task here. You can do a search from here. And the tasks you see here, they are available already in my account. But it's also actually searching automatically on the marketplace to see are there any other tasks that matches your search criteria. So it's very easy now to say, okay, actually I want to use this task maybe. So I just hit on get it, and that will bring me to the marketplace. So there is now this common marketplace for Visual Studio extensions, Visual Studio Code, and Azure Devops. So the list of available extensions just keeps growing. And it's really easy now to just grab it and install it into my account. So if I want to, I can just click on Get It Free and install it, and then I can use this build task in my deployments. All right, so let's just see if this build is now completed. It should be. Yep, it's nice and green and nice. So when this build now completes, that will actually kick off a release. That's the next part of my deployment pipeline. And we should actually be able to see that on the summary here. So at the top here, we can see now it says deployments up here. And so I can see now it's actually being deployed into a test environment. I'm going to zoom in a bit so you can see here. So I have a deployment pipeline here that goes first into a test environment. And so let's take a look at how that is defined. So I'm going to go into the release tab. Deselect something here. So this is now the release definition. This is where you define your different environments, your stages in your deployment pipeline. So that means that you don't normally just deploy right into production. You want to deploy into some maybe multiple testing and staging environments, and you want to run tests on those environments before you go into production. So here I can see the history for this QuizBox release. Currently, it's showing me what's currently deployed. So I can see, for example, now test is currently running. Currently, it's release 1.2.4 that is deployed there. In production, it's release 1.1.2, which was deployed a couple of days ago. So I can easily see which version is deployed onto my different environments here. And let's go into this one that is running now. So this is what the release definition looks like of a running release. To the left, you can see the artifacts, and that's what's going into this release. So in this case, I'm deploying both the web and the API in the same release definition. I also have some, I'm deploying this to Azure, so I also have some ARM templates for actually creating my web apps and SQL servers and so on. So all these artifacts now go into this release. So I can see now, for example, this is version 1.0.24 of the API and 1.0.84 of the web application that goes in here. And now it's currently being deployed into the test environment, and I can view the live logs. And as you can, when we come in here, you see it's very, very similar to the build side of it. So it's the same framework, same tooling for build and release. So now I can see the live logs coming from the deployment to the test environment. And this is still running, so let's look at a previous release that I ran earlier, just to show you some more information. So this one ran through the test. Now after the test environment, if that goes well, I want to run some tests, some integration tests towards that environment. So this deployment pipeline now, it fans out and runs some UI tests. I'm using Selenium to run some UI tests. And in parallel with that, I'm also running some regression tests. So this is done automatically. Every time I check in, this is done automatically for me. At the bottom, I also configured that I want to run some load tests. And this is something that maybe I don't want to do on every commit. So in this case, I'm actually saying that that's optional. I need to approve that before that happens. So let's take a look at how we edit this pipeline, this release definition. So we go into edit mode, and it's going to look, exactly the same. So this is where I define my stages of the deployment pipeline. So if you go into the test environment or test stage, again, you can see that this is the same task that I showed you before, but now it's being run in the deployment instead. So I'm deploying my environment, my resource group in Azure, and then I'm deploying the web app and the API app onto that app service that has been created for me. If I switch to, for example, the run UI test, I'm just using, it's very simple, I'm using the built-in VS Test task. In this case, I have some test assemblies that contain these Selenium tests. So if you just quickly take a look at the configuration of this task, I'm specifying that, run all the tests that have the name UI test in it. So I'm just using a naming convention to specify that these are the UI tests. You can do that in different ways. That's how I've done this in this case. Also, when you deploy your application onto multiple environments, it's really important about the configuration. So you're building the application once, so you have your artifacts. Then you take the same artifacts and you deploy it to multiple environments. But those environments are not exactly the same. You will have different logins, different passwords, and so on. So you need to capture that somewhere and use it when you actually deploy it. And you do this by using variables here in Azure Pipelines. So here I can define a set of variables, and I can specify the value for this variable for each environment. So I can scope down this a bit to make it easier to see. So let's, for example, compare the test and prod, and also release. So let's do like this so you can see something. So now you can see that I have a set of variables. and these are the values for the test environment, and these are the values for the production environment. So for example, the name of the app service will be different. And in some cases, it's the same value across all stages. That's why I'm defining as a release variable. So it's different scopes here. So, when I deploy it to test, Azure Pipelines will take the values from the test stage and use that to deploy and update, config files and so on. And when I'm deploying to production, it will take the values from this stage instead. So this information is now safely tucked away here. Now, some of this information is typically sensitive, passwords, for example. So I have a variable called db password here. And in this case, I'm actually referring to another variable here. So a variable that I call vault db password. And that variable is defined in a variable group. So a variable group, that's something that you can create and reuse across multiple builds, multiple pipelines. Because it's very common to deploy several applications onto the same environment, and you don't want to repeat this information for every build and release. So you can create a variable group to capture that information. And what's nice is that in addition to keeping this in one place, it also lets me integrate with Azure Key Vault. So I can store sensitive information right in Azure Pipelines. I can mark them as secret and they won't be shown. But an even better solution is actually to link this to Azure Key Vault, which lets me do things like expiration and key rotation and those kind of things. So I have an option here to link these secrets from the Azure Key Vault, and I have the integration right here. So I've selected an existing Key Vault here, and I define my secret variables in there, and those variables will now automatically be available in this deployment. So that's very nice. So let's take a look at the release that is running. So it's actually completed the automatic tests. And it's currently waiting, currently doesn't do anything. It's, as I mentioned before, the load tests is, I've added a manual approval step here. So this one is now waiting. So if I want to, I can approve this now. That will kick off load testing. But I don't want to do that every time. That's why I'm keeping it manual. But these other tests, they have already been run, and they succeeded. And you can see that it exposes kind of the overview test information. But then I can drill down into these tests and see test information from this deployment. So it looks very similar to the build. And nothing failed, so by default it only showed failed tests here, but I can drill down into individual tests here. And for example, I can see the history of this test as it has been running. And typically I want to see things like how long did it run for? How does it look over time? Is it flaky or not? Because these are integration tests, and they are also a bit problematic. So very good detail here and kind of result analysis. And this is also available just by looking at the definition. I get also an analytics tab here. So that by default is going to analyze my test results to see how is this deployment going over time. Do you have a problem with failed tests? So in this case, it says that your pass rate is 98.84%. And I can now drill down and kind of troubleshoot these failing tests, because that's very problematic in a deployment pipeline to have tests that are failing sometimes. So it'll let me identify them for me, and I can go into them and analyze them. All right. So the change we made is now in production, in tests. So if I refresh this now, the test site running in Azure, you can see that now this change is running there, which is nice. So let's change to the admin team instead. They are building stuff from GitHub. So they are not using Scrum, so they don't have like this sprint planning. So they're using the Kanban board in Azure Boards. So instead, they're just adding stuff over here, and they're trying to identify what's most important right now, and trying to deliver that to production. So they're using the board functionality, and this is very customizable. You can add columns, you can add styling, and so on. So it's a really good tool for doing Kanban. So what you want to focus on here is kind of the flow, trying to get stuff into production and avoiding bottlenecks during this process. And that can be shown here in the cumulative flow diagram, that you can kind of easily identify if you have any bottlenecks here. So in this case, they have their code in GitHub. So I have this solution open here in Visual Studio. So now I'm connected to GitHub, and I'm just going to make this very simple change that I prepared. I'm just adding some stuff into one of the views. Added new feature. I can also actually, in this case, they are using Azure Boards, but they're using GitHub. But I can still actually link this commit to the PBI that I'm using. The integration is not as good. It won't automatically show up here. So, but I'm going to use the AB PAM notation. So AB is for Azure Boards. So if I type AB and the square, that means that, okay, it's going to link this commit to a PBI in Azure Boards. So let's go back here, and I think this is the PBI that I'm working on, the 1764. So I'm just going to type 1764 here and push it. So that means that there is an integration here between GitHub and Azure Boards that will now link this commit in GitHub to the PBI in Azure Boards. So I still get this traceability, which is very nice. So as soon as this has been published, we should be able to see that link. Come on, push it. So in the meantime, let's go to the GitHub site. So nothing that interesting about this application, really. And can I see if it's published? It should be published. Yeah. So let's go into the pull request here on the GitHub. So the pull request experience is kind of similar now between Azure DevOps and GitHub. So we get the same thing here. It noticed that I have made a new branch, so it suggests that I should create a pull request. And in this case, I'm just going to quickly create it. But still, I want to make sure that this code, before I merge it into the master branch, I want to make sure that it's a good quality. And GitHub has the same kind of functionalities where you can add these kind of policies in the same way. So what's cool now is that I've connected my Azure pipelines to the GitHub, so I can build it. And in the same way that we saw before, it now kicked off a build here. So you can see that GitHub has this concept of checks, and this check now is actually kicking off a build here. So it's running my QuizBox admin build now to validate this pull request. And if I drill down into the details here, I can see information about this build, and I can actually go directly to it. And then I'm, jumping back into Azure Pipelines to see the build that is currently running for this pull request. So even though I'm not using Azure Repos, I still get this traceability, I still get this build validation and pull request validation to make sure that the code going in there is of good quality. So the build is running, and as soon as this build is complete, I will be able to merge the pull request. All right, it's done. And so let's go back to the pull request here. So it should now the health check, or the check, is marked as passed, which means I can merge this pull request. Confirm it, and so same procedure basically as in Azure Repos. And again, now I'm merging it to master and going back here to the builds. that again should now kick off a new build for the master branch in the same way. So I'm switching to QuizBox admin here. Yeah, so it's running. So when that build completes, it's also going to start off a new release for the admin tools. And so in this case, I'm not deploying it to Azure. I'm deploying it to on-premise machines instead. So let me show you how that is set up. So in this case, I just have a test and production stages. And in the test, I'm simply creating a website on the IIS, because this is an on-premise machine, and then I'm deploying the app to that machine. But these tasks are now run within the concept of a deployment group. So a deployment group, that is basically a set of agents that are running on a set of machines. And that lets me do things like, for example, I can say, roll this new version out to multiple machines, but do it 50% at a time. So in this case, I have 2 machines, which means that it's going to first deploy this new version to one machine. And when that is done, it deploys the version to the other machine. So you can do kind of a rolling upgrade here. Or you can just run everything at the same time. So it makes it very easy to deploy onto multiple servers like this. Okay, so we made our changes for both these teams. We pushed them into the test environment. So we want to test it. So let's go into the Azure test plans part of it. So if you remember the game team, they are using this kind of formalized testing. So they are building test plans. They're creating test cases for their acceptance testing. So we're going to see how that looks like. So this is the test plan for the game team. And you can basically structure this test plan in any way you want. In this case, I have created kind of a folder for each sprint. And inside each sprint, I have each requirement. So every requirement in that sprint will become its own test suite. Because typically, a PBI, a requirement, will have multiple test cases. So if I look at one of these requirements, post high score on web, I have 2 test cases here. Here I have the select random category. That's the PBI that I'm working on. And I already created the test case before. So let's take a look what that looks like. And the test case is also a work item, so it's very similar to a PBI or a bug. But what's different about it is that it has these steps. So this is what you would write in a Word document or Excel document. Otherwise, you have a set of actions, do this, and every action has kind of expected result. This is what the testers should verify when they run the test. So I can create test cases. I can create test plans from these test cases. I can, for example, create test suites for, in this case, regression tests. So put all the test cases that you should run on every release. I have a set of automated tests. So these are test cases that are mapped to an actual implementation. So I can run these tests, some of these tests automatically. But as a tester now, when this test is done, when I want to test this new feature, I can now run the test from within Azure test plans. So that gives the tester kind of a nice experience running through this test. So you get a little test window here that shows you the test or the test case. And when going through this test case, they can just mark each step as passed or failed. So here you can see the steps that I defined. And so the idea now is you can dock this window. So typically you would have maybe 2 screens for this. So let's do like this and head back into our site. So now as a tester, I have the test case over here. So I can start the test or run through it as it is described. And during this test case, I can add information. I can do screenshots. I can actually do video recording. I can capture all logs. Everything that I do now as a user is now captured. So it will capture which button did I click on, where did I click on, and so forth. And this is really valuable information for the developers if the tester finds a bug. So let's just run through the test case. So start a new game. So okay, that worked. Select random category, and the expected result is that the first question in one of the categories should be shown, so it looks good. And so the test case now says, okay, run this multiple times, and you should be verified that it's actually random. So okay, I'll do it once more, and hopefully it's another one. Okay, so everything looks good here. So, but it's probably the same, just because. But it is random, I promise you. So, okay, but maybe it's a bug actually. So let's pretend it's a bug. It wasn't the same. I always get the same category here. Okay, so I marked this step as failed. And I write a comment. It always returns the same. And now I can also add, for example, if the developer don't believe me, as tester, I can now add a screenshot. Come on. So let's do like this. And I can annotate the screenshot and say, hey, it's actually the same, and so on. So I can add a lot of information here. And this information is now stored within this test run. And once I'm done here, I can now create a bug. And this bug will go straight back into Azure Boards, and we'll get all this information. So this is really nice for the tester because I don't have to repeat all the information. I don't have to explain what I've been doing up to this point, because that's recorded. All the steps in a test case is marked, and the action recording is done for me. So I can just, add a title here. Select category doesn't work. And this really reduces the kind of friction that can go on sometimes when the developer said, hey, it works on my machine, you probably did something wrong. And the tester doesn't have to spend a lot of time filling out detailed bug reports because it's done for them. And just going to close this one because I already created a bug. So let's take a look at the bug that we created. So it's a bit hard to steer here. Come on. I apologize for the slow internet connection, apparently. Okay, so we have the bug down here that was created for me. And so me as a developer, I can now open up this bug. I probably get an email, a notification saying you have a bug waiting for you. And I can fix it, go back in, and then the tester can verify the bug by running the same test case again. So apologize, but it's really slow now. Okay, I won't wait for it. So, but to show you the difference, if we talk about the other team that they don't have these test plans, they haven't built test cases, but they still want to have these nice bug reports. So instead of creating all these test cases, they can also use the test and feedback extension, which is also kind of part of Azure Devops, but this is an extension for Chrome and Firefox, and soon Edge, that you can install. So it makes it really easy for testers to just start running some exploratory tests, but still get this tooling that records your actions and lets you capture feedback and so on, and still create this rich actionable bugs. So what you do when you install this extension is that you connect it to your Azure DevOps organization, because that will allow it to publish bugs right back. And then I can just start a session. And that means that when I start the session now, it will record everything that I'm doing here. So I can click along here and click next. Maybe something fails. And during this session, so that was actually a bug, these steps that I click on will be recorded. I can also add comments during the way. Pretty slow. Again, I can add screenshots, and in the same way that I did before. So I can also use this tool as a kind of a feedback tool during the sprint, for example, or during development. So again, this information is captured now during this session. So clicking here, we can see the session timeline. So you can see that all the steps I'm doing is being captured here all the way. And if I create a bug now, this information will also, be posted back together with this bug. And so a lot of good information for the developers, and makes it a lot easier to find the bug or to reproduce the bug because you have all this information already. All right, so I'm actually out of time. I apologize for this slow internet connection. So I won't have time to show you. I will very, very quickly just show you the last step without finishing it through. Because now we have this release, I've tested it, and I want to have it into production. So the final step is to get it into production. And one way is to just, of course, approve it and say, okay, let's put it into production. But if I want to automate that step, I can use something called release gates, which is a way to implement this automatic validation. So maybe you saw that before, but this release that we've been running, it was actually kind of trying to get into production, so to say. But it was waiting because it's evaluating these release gates that I've defined. It's enormously slow. Okay. Let's try one more time. Come on, you can do it. Oh, it's really slow. Okay, so anyway, so in this case, what I did define this release gates was that it will check. So there are some predefined release gates here that I can use. One of them is to actually use application insights to check the current status of my production environment. So I want to make sure that my production environment is not unhealthy before I deploy it. And that I can check automatically. I don't need to check that manually. Also, I can check that if any of the tests have reported bugs, it won't continue. And you can also do this. You can call any API here during these release gates. So if you have a custom way to actually validate your deployment before going forward, you can do that here. So, okay, it seems to be too slow here, unfortunately, so I apologize for that. And, well, with that, I want to say thank you. I hope you got something out of this, and I'll stick around if you want to have some more questions. So, thanks.